here we go. Okay, so last time, if you remember, what I presented was the division algorithm, okay? Now, this is again what it says, if you remember, all right? Basically, if you have a polynomial, right, capital F of x, and let's say you decided to divide it by a non-zero polynomial d of x, okay? Non-zero polynomial, meaning d of x is not identically zero. Then it turns out there are two unique polynomials, okay? Q and R, Q of x and R of x, okay? Such that this is true. F of x over d of x equals Q of x plus R of x over d of x. Or equivalently, f of x, okay? You can write that as Q of x times d of x plus R of x. And here, R of x, is the remainder. Q of x is the quotient. D of x is the divisor. Capital F of x is the dividend. And if you remember also, R of x is either identically, well, it's right on the slide. R of x, the remainder, it's either identically 0 or its degree is less than the degree of d of x. Either one of those. Has to be one or the other. So, okay. So what I want to do now is I want to do another example of long division, polynomial long division. Then we'll do some synthetic division. All right. So again, let's say we're dividing this here, this polynomial, okay? 2 times x to the 4 minus x cubed and so on, okay? By x squared plus 1. And again, we're using polynomial long division. Now, excuse me, the last set of notes I sent you last time, that had the list of, of the procedure for polynomial long division. And remember, we had to put a 0 in for missing terms. In other words, if we're missing a term, we put the term in with a 0 coefficient. That's a better way of saying it. So here we have 2 times x to the 4, okay, minus x cubed plus 3x squared minus 1, right? We're missing the x term. We put it in, but with a coefficient of 0. Now, do you have to do that? Honestly, I don't know. That's what I'm doing. Because I do know, for instance, with other procedures, for instance, if you were multiplying using the grid method, you can actually put in missing zeros. For missing terms there, you can use 0 if you want. Some people do that. You don't have to, but again, the way I'm doing this, I'm putting in 0 for a missing term. If you don't, like on a test or something, but if you do everything correctly, using polynomial long division, that's fine. I'm not going to take points off if you do something slightly different, which is correct. Hope that makes sense. For x squared plus 1, notice we're missing the x term, right? We're putting it in with a coefficient of 0, okay? With a coefficient of 0. That's what we're doing here, okay? And now we divide. Remember, this here is our dividend. This is our divisor. And what you want to do, okay, is you divide leading terms. So for instance, 2 times x to the 4, right? You're going to divide that by the leading term of this, which is x squared. Doing so, you're going to have 2x squared. You have 2 over 1, x to the 4th over x squared. That's 2x squared. You're going to put that over its like term in, above, in the, here. sorry, messed up my words. It's going to be over the like term, okay? You know, above the dividend. And then just like in long division of real numbers, what do you have to do? You multiply, right? You're going to take the 2x squared and multiply it by this whole divisor. Then you subtract, okay? You subtract. And then when you subtract, right, you're going to subtract this. This is the product. And again, when you subtract, right, I mean, this is what I do at least. This negative I distribute, right? I change subtraction to adding the negative, and the negative I distribute. That's what I do. So we get this in other words. Okay, so we're combining these. They vanish, right? 2x to the 4 plus negative 2x to the 4, gone, right? Negative x cubed plus negative 0x cubed. Well, this is just really 0, so we just get negative x cubed. 3x squared plus negative 2x squared, we get x squared. The 0x we bring down. That's our next term. Okay, that's what we bring down next. That is our next term. Now, do we repeat the process? Well, we have to, right? We only stop when the difference has degree less than the degree of the divisor. Okay, so when this difference here has degree less than the degree of the divisor, that's when we stop, or if the difference is 0. Okay, so here we have negative x cubed, it's actually down here, negative x cubed divided by x squared, that's over here. As you can see, we get negative x. This negative x comes up here, right? Again, you put it over its like term, then you're going to multiply, right? Negative x times the whole divisor, and you subtract the product. So you have negative. So right again, we're subtracting negative x cubed, 0x, negative 0x, I guess, and 1. Negative x, I mean. And again, you know, you could subtract directly. What I like to do is I change this minus subtraction, that is, to adding the negative, and then I distribute the negative. Since these are all negative, it's all going to be pluses, as you can see. Now we combine. These cancel. Negative x cubed plus x cubed, gone. X squared plus 0x squared, that's x squared. 0x plus x is just x. The minus 1 we bring down. That's what this arrow indicates, right? Bring it down. Bring that down. So now, do we stop? Well, no, because the degree of this difference equals the degree of the divisor. We want this to either be 0 or have degree less than the degree of the divisor. Okay? All right, so what do? We divide. Leading terms, right? We have x squared divided by x squared. We get 1. We get 1. Excuse me. Okay, so where does the 1 go? Well, 1 goes above its like term. It's going to go above here, right? As you can see, because the 1 is above the negative 1. Then we multiply. So we have 1 times this, which is just x squared plus 0x plus 1. We subtract it. So we get that. We subtract it. Okay? And once we do that, you know, again, I change it to adding the negative and distribute the negative. Doing so, what happens? Well, the x squares are gone. Here we have x minus 0x. Well, plus negative 0x, which is just x squared, which is just x. Negative 1 plus negative 1, that's negative 2. Okay? That's what we get here. Now the question is, do we stop or do we keep going? Well, here we can stop, actually. Now, why is that? Well, because Here, the degree of this is 1, which is less than the degree of this. So now we can stop. So here we can actually stop here. Okay. And so we get our quotient is up here. The remainder is x minus 2, as you can see, and here's how we write it. So that's what we get. And that's what we get. And of course, you can also write it this way if you want. They're both equivalent.